So hi, welcome to Module 3, where we'll be focusing on spatial and also geostatical analysis. So for the first part of our module, which is spatial analysis. So basically, spatial analysis is to overcome problem of limited ground sampling. When we have a problem where we can't do ground sampling, we do spatial analysis in ArcGIS. And the process of examining the location, attributes, and relationship of the features in the spatial data through overlay and other analytical techniques. In order for us to address a question or to gain useful knowledge. So that is spatial analysis. So the first step in spatial analysis is to do buffering in ArcMap. Okay, so the way we do buffering is we take our derived SHP, drag it to table of contents, and then we will go to our toolbox, and then we will click on analysis tools and then proximity, and you click buffer since we want to do buffering. So at the display window here, our input features is derived SHP, output feature is, okay, we want to put it here, so we will rename it to derive, and then click save over here. The linear unit that we will use for our buffering is 300 meters, so make sure the distance here is in meter, and then the dissolve type is we will do all. First we will do all, and we will see the difference between all and also none, so just click OK. So it's buffering here, as you can see it's loading. Down here the buffering is done, so let me see. So this is the buffering 300, as you can see over here. So for the display, dissolve type was all. So now we are going to try to create another buffer. But now we will change the dissolve type to none, and we will see the difference. So just same as just now. It's all the same as just now, but the dissolve type we will change to none. None dissolve type, and just click OK. So it's buffering. And then we will see the difference between the layers. So now, okay, let's pick a corner over here. So as you can see here right now, I have in green is the none. So when the dissolve type is none, the difference between the dissolve type is actually for none. An individual buffer for each feature will be maintained regardless of the overlap. So as you can see here, the individual buffer is maintained regardless of the overlap. So if we try to look at our buffer where the dissolve type is all of the output features here into a single feature. It means that all of the buffer dissolve together into a single feature, removing any overlap. So that's the difference between the dissolve all and also dissolve none. This is dissolve all and this is dissolve none. You can clearly see the overlap over here. The individual buffer for each of the features is maintained. Okay, so when is this important, the dissolve all or dissolve none? The dissolve boundary tool actually merge areas that overlap or share the common boundary into a single area. So basically it simplifies boundary from a more complex one. So if you want to simplify a boundary, let's say a road, where we want to simplify an area, so we can use the dissolve tool to simplify the complex area and to generalize it. Okay, so now done with buffering. Now is we are going to do overlay. And we are going to do 3 types of overlay in this module, which is erase, and then we're going to try union and also intersect. And then we will look at the differences of all these 3 overlays. Which is also a practical highlight question, number 2, which is captures each overlay analysis done and explain the overlay feature. Overlay is basically identifying the relationship of each layer. So we're going to do this. The process is basically the same as just now, but okay, we do overlay and then we'll analytic tool, we click on overlay here and then we click erase. The input feature is buffer HSP just now. This one. The erase features that we are going to need is derive HSP. Okay. So erase actually is an analytical process in which output features in a class is created by copying the portions of the input features that lies outside the boundaries of the erase features. So in other words, the erase tools is used to perform overlay analysis on feature class. Later, I will show you. Once this is done, I think you will see. So the output destination, we made as derive buffer. Okay, and then just click OK. So now it's erasing over here. Okay. So this is our erase. It's different from buffer because just now we erase features was derive SSP, right? So you can see here in the middle, the derive file is erased from here. So it's not here because it's use of erase feature. So if you want to see, this is the derive, and this is the derive buffer. Sorry, derive erase. Okay, so now we are done with erase. Next we are going to do is we are going to union. So are we going to do union? Okay, open here and then we are going to go overlay and then just click on union over here. So we are going to union 2 input features, which is first derive buffer HSP, and also this one is under module SDA district Kelantan. So basically, union is combining two input data layers into a single composite layer without mixing the boundaries and also attribute from all the input features. It means that they preserve the boundaries and also attributes from the input features. So now here is done. The output feature here, we are going to rename it as Derive District Union. Just click save over here and just click OK. So now it's loading here, combining all the tools of input data. Basically, it is combined layers. And we can zoom to layer. So this is it. We already combined the district Kelantan and also the buffer that we did just now derive. So we can also look at our attribute tables to see buffer here, polygon, and also district, and there's a name here. Okay, so that's how we do union. Okay, so next what we're going to do is we are going to intersect. Intersect is basically the tools to calculate the geometric intersection of any number of feature classes and also feature layers. Section, we click analysis tool here, then we click overlay, intersect. So for the intersection that we are going to be needing is derive, SHP, and also district Kelantan. So this is the two input features that we will be intersecting together, and the output features we need to save it as final SHP output for the output feature class. Then just click OK. So in the output feature class here, it's loading here. The features that are common to all inputs, where the intersect will be written in the output feature class. So here is our final, where it intersects. Alright, so that's it for part 1 of buffering and upmap for the spatial analysis and also overlay. So before we proceed, I forgot about the third practical highlight question, which is how is the XY tolerance defined in the intersect dialog and how many records does final SHP have? So just open here just now, I'll just show you. Okay, this is the XY tolerance box here in the intersect dialog. And the XY tolerance box is actually referred to the minimum distance between coordinates before they are considered equal. And in this intersect dialog, the XY tolerance is left blank. It shows that there is put under default setting. And then for the final output of our intersect in our file, we just click open the attributes table. And here down here, you can see we have 343 final records at the end of the discrete intersect between the two files that intersect together, which is district Kelantan and also the derived buffer. Okay, so now for the second part, which is geostatical analysis. So geostatical analysis is basically where we incorporate spatial coordinates into the data that we want to analyze. As you can see here before, we already have our data in Excel format, which is how to analyze geometrical data in GIS, and the ground measurement is 10 pm, and N and E here is the coordinates, and we have stations. And we are going to add it in Daerah HSP. So first we are going to open our art catalog and drag Daerah HSP to our layer. So we have here, and then we are going to convert our Excel to table. So we open our art toolbox, and then we open conversion tools, Excel over here. We're going to do Excel to table. So the input file that we want to choose is the Excel that we want to change. So we look for our thing here. So we have our data here, and it will automatically have our input table here. So we just click OK. So now here, it's converting the Excel. Okay, so now our Excel the table is already over here. So now we are going to add data into points. So here we are going to do display X and Y data, where we are going to add the coordinates. So just now, as we look at our data in Excel, here N and E is the coordinates for X and Y. So N is for X field here, and the E here, and the Z field is none. And make sure the coordinate system we're using is WGS 1984. Then just click OK. So this is the final result as I zoom to layer just now. This is the coordinates of the 1, 2, 3, 4, 5 discrete in the data ground just now. It's now in our Daerah file. So now we are going to export the data to shapefile format. So how are we going to do this? Is just right click at the point data ground. And just click data here and export data. All features. So the output here, and the name here, rename as the ground data. 1 July 2015. And don't forget to change the file as type shapefile since we're going to. And just click OK. So this is our shapefile that we just created just now. Okay, so now for the final part of our module 3, which is geostatical analysis. So geostatical analysis is basically when we want to generate surface from a data to predict for better decision making, because it's not always possible to predict a model spatial phenomena through real life world. So we do geostatistical analysis in ArcGIS. So first what we need to do is we click on customize, and then we click on extensions, and make sure the geostatistical analysis here is click, and then we'll add the geostatistical to toolbar. Here, geostatic analysis, make sure it's add. And if it's not appearing, oh, here it is. So we can drag it on top here. Okay, so now let's perform our interpolation. So interpolation is basically creating a surface data from sample points. So we are going to create an interpolation for surface PM10 using geostatistical analysis setting. So first we go to geostatistical analysis here, and then we will click on geostatistical wizard. So spatial interpretation is interpolation is basically a process of using points with known values to estimate values at other points. So here is two ways where we can do interpolation. First is inverse distance weighing. So I'll show you how we do inverse distance weighing. So inverse distance weighing here, and then here we have data field. So the data field here, we will click in PM10, and then click next, and then here click next again, and then click finish. Just click OK. Alright, so here is our interpolation. Next, we're going to click on here, layers, data at the table of content. Then we right click and properties. And then we click on the data frame tab over here. And then we will change, make sure the extend is automatic, and then the extend used by full extend command here, we will need to click other and then specify. We will click outline features, and then we will search for daerah. Make sure it's all, and then press OK. And then for the second click option, we click to shape, and then over here, specify shape, other outline, and daerah, and then all, and then click OK. Then click apply, and then click OK. And then we click on our inverse distance layer here. In distance weighing layer here, we click on properties, click on extend, and then make sure here we will change it to extend of daerah, rectangular extend of daerah. There's a lot here, so make sure you click on the right one here, rectangular extend of daerah. Click here, and then just click OK. Okay, so here is our inverse distance weighing for interpolations. Here is our daerah. Change it to hollow so that we can see. Enable features. Okay, so we are done. So don't forget to save your file for inverse distance weighing. Okay, so now for the second part of interpolation, which is cringing. It's a second type of interpolation that we're going to do. It's basically the same as what we did with IDW. So we click geostatic analysis here, and then we click on cringing over here. Then make sure it's in PM10. And then just click next. And over here, cringing type is ordinary. Output surface type is prediction. Here we click on next. Next. Click finish here. Let's click OK. And then over here, the cringing here, we are going to go to properties. We're going to look at extend and make sure the extend here is a rectangular extend of daerah, same as just now. Just click OK. And then make sure the inverse distance weighing is unticked in order to properly see. So daerah here, we can pull up here so we can see the daerah, top of cringing here. So yeah, this is the final output of our cringing. Don't forget to save file. So thank you for watching.